Good day everyone. This is our final project in hydrology named Watershed Modeling, to be discussed by me, Jewel Pascor, and my partner, Machu Laksina, and other group mates, Erwin Pangilinan, Willie Aguilar, and Elmer Gina. First of all, what is watershed? Watershed modeling is advanced in the understanding of physical, chemical, and biological processes influencing water quality coupled with improvements in the collection and analysis of hydrologic data provide opportunity for significant innovation in the manner and level with which watershed scale processes may be explored and modeled. And these are the terminologies that we use in watershed modeling. First is watershed, an area or the ridge of land that separates water flowing to different river basins or seas, or an event or period making a turning point in the course of action or state of affairs. Basins. A basin is a depression or dip in the earth's surface. Basins are shaped like bowls, with sides higher than the bottom. They can be oval or circular in shape, similar to sink or tub you might have in your own bathroom. Some are filled with water, others are empty. Basins are formed with force above the ground, like erosion, or below the ground, like earthquakes. They can be created or thousands or years or almost overnight. The major types of basins are river drainage basins, structural basins, and ocean basins. Subbasins is the structural geological features where the large basin is divided into a series of small basins with interrelating intravasinal heights. River drainage basin is an area drainage by a river and all of its tributaries. A river basin is made up of many different watersheds. Next is the reach, an extension portion or stretch of land or water, a straight portion of a stream or river as from one turn to another, a level stretch as between locks in the canals, all arms of the seas extending up into the land. Next is junction, a place where two things join together or the connection between them. Next is the background of study will be discussed by Machu Laksina.
Background of the study. It's all about Nueva Ecija. It's a landlocked province in the Philippines located in the central Luzon regions. Its capital is the city of Palayan. Nueva Ecija borders from the south clockwise Bulacan, Pampanga, Tarlac, Pangasinan, Nueva Vizcaya, and Aurora. The province is nationally known as the rice granary of the Philippines, producing the largest rice yield in the country. The history. Nueva Ecija was named by the Spanish colonizers after the city of Ecija, Spain. Its indigenous names such as Pinagpanaan, meaning the place where the arrow hit, defining the pre-colonial artistry in archery in the area, were abolished and changed by the government during the post-colonial period after World War II, sparking outrage from scholars and indigenous communities. Nevertheless, the name change of some municipalities into colonial names during the post-colonial period was continued by the national government. Nueva Ecija, the country, Philippines, region Central Luzon, is located in Region 3. Founded April 25, 1801, 1848 on old sources, the whole area of the Nueva Ecija is 5,571 kilometers squared. Its capital is Palayan City. Pantabangan Lake. It is our sub-basin. It's an earth-filled embankment dam on the Pampanga River located in Pampanga, Nueva Ecija province of the Philippines. The multi-purpose dam provides the water for irrigation and hydroelectric power generation, while its reservoir, Pantabangan Lake, affords flood control. The reservoir is considered one of the largest in the Southeast Asia and one of the cleanest in the Philippines. Its catchment area is 853 square kilometer. Total capacity 2,996,000,000 cubic meter. Then, Pantabangan Lake, official the municipality of Pantabangan, is a first-class municipality in the province of Nueva Ecija, Philippines. According to the 2015 census, it has a population of 29,925 people. This is the site of the Pantabangan Dam and Lake, located in the northern part of Nueva Ecija. Pantabangan is located at the foot of Mount Mabilog below Mount Dilimanok, which are found between Sierra Madre and Caraballo mountain ranges. It is home to Pantabangan Karanglan Watershed Forest Reserve. So this is the Pantabangan Lake. These are sub-basin that we'll be using in our watershed modeling. Then, our methodology. First, research of math and plotting of contour lines. Develop a basin model, collecting of data, determine precipitation, parameterize the basin model, add stream flow and precipitation gauge information, create a meteorologic model, create and run a simulation, calibrate the model and evaluate model performance, create and certain analysis and evaluate results. Then, this is how we get our contour lines. First, we need to download this application right here, the Google Earth Pro. Shout out Google Earth Pro. Then, by using this application, we can now get our area by plotting these lines right here. Then, these red lines right here. Then we can get our contour lines for our watershed modeling.
After we run the Google Earth Pro, this will be our result. This will be our contour lines. Then this will be the Pantabangan Lake right here. Then the water flows down, goes here at the boundaries of Pampanga. Then next will be our sample computations. Storage. First we need to get the storage, then the lag time. Then S stands for storage is equal to 1000 all over Cn. Cn stands for curve number minus 10. Then lag time is equal to HL. HL is the reach. So we can get the reach. Reach will be from here, and the subbasins goes here. So reach raised to 0.8, then the quantity of S plus 1 raised to 0.7 all over 1900 multiplied by the slope raised to 0.5. How we can get the slope? Slope is rise over run. Then how can we get the distance from here? We use the distance formula. Then the height of our subbasins. The height of our subbasins is 1000 all over the distance. So we get the slope 2.67. Then solve for CSE method. Then Cn is equal to 2.67 plus 3.16. This will be our answer, 5.92. Then the storage. We can get the storage. Storage is 158.91 inches. Then the lag time. The lag time is equal to 185.4.
So these are the results based from our computations. So we got here a basin model. We can get it to application which is the HEC-SMH. Then we plot here our sub-basin. We got one sub-basin here and two junctions and two ridge. So next we compute the from the sub-basin one we got its drainage area, which is 853 kilometers squared. Then its peak discharge is 67.9 cubic meter per second. Then time of peak, it is on August 3, 2003. Then the volume is 28.22 millimeters. Then this is the hydrograph based from the past computations right here. Then we plot it on the hydrograph and hydrograph. This is the hydrograph right here, and this is the hydrograph. So next, junction 1, same as the how we get the sub-basin one right here. We got this drainage area, which is 853 kilometers square, the peak discharge is 67.4 cubic meter per second. The time of peak is August 3, 2003. Volume 28.64 millimeters. Then this is its hydrograph right here. Then the junction 2, same as how we get the other two. We got its drainage area 850 kilometers squared. Then peak discharge 65.7 cubic meter per second. Time of peak August 3, 2003. Then the volume 3.88 millimeters. Then we got its hydrograph, and these are references. That's how we get our watershed model.